Hello Science 10 and welcome to the lesson on acceleration. Today we're going to be learning that in order for an object to accelerate, it has to have a change in velocity. So our goals today are to define the term acceleration, understand the relationship between velocity and acceleration, and then quantitatively, and as a reminder, quantitatively means with numbers, evaluate acceleration given data in a variety of different ways. We are going to talk about acceleration, and this small video embedded here I will post separately so you can see. It just talks about the differences between speed, velocity, and acceleration and how they all relate to each other. So what we've learned in physics so far is vectors and scalars, and specifically when looking at vectors and scalar, we've looked at distance, displacement, speed, and velocity. And so we talked about what that means by uniform motion, and we came up with the word linear. And the word linear meant in a line, so a straight line. So that's what these graphs are demonstrating, is just how we can represent uniform or linear motion. But now that we're looking at acceleration, that's going to change the story. Acceleration is still a vector quantity, but now we are going to focus on the change of velocity. So velocity isn't just a constant anymore, constant speed or constant velocity. Instead, we're going to see some changes. So an object is considered accelerating if it changes its velocity. So if our velocity increases or decreases. If we do not see a change in velocity, if our velocity remains constant, then that just means we're not accelerating. So as the picture shows up beside is this person is running, so they're speeding up, so their velocity is changing, so they're accelerating. Same with slowing down. If you're on a skateboard and you're coasting and then you come to a stop, that's also considered acceleration because your velocity is changing by slowing down. One that we don't talk a lot about in Science 10, but is also considered acceleration, is when something changes direction. And that is also considered accelerating because the velocity will change as they change direction. So here are the variety of different types of acceleration. We have positive acceleration and negative acceleration. At this point, pause the video, write all four of these pieces in. Really, what it's just showing you is that you have two types of acceleration, and because acceleration is a vector, you have to remember that sometimes magnitude and direction are going to be in the same direction or in opposite directions, and that's what creates that positive or negative situation. The video in the corner, again, I will post separately as it shows you why two negatives make a positive. Finally, here is our acceleration formula. So you're going to want to pause, write this down, and include all the pieces with it. Acceleration is represented by the letter A, and we usually put a vector form over top of it because this is a vector quantity. And we can find acceleration by using final speed and initial speed divided by time. So what has to happen is you have to use all of these pieces of information to find acceleration. Now, if you do not have a final velocity or an initial velocity, you can just use the velocity within the formula. So if you're given one velocity, you can do velocity divided by time. If you're given two velocities, you're going to look at the final minus the initial divided by time. So let's take a moment to do a couple practice questions and look at a few. So let's look at a car stopped at a red light when it turns green, and the car accelerates away after 6 seconds. The car is traveling at a rate of 4.25 meters per second west. Let's determine the acceleration of the car. So first, we're going to use our formula acceleration is equal to velocity over time. Now you'll notice this one does not have a final velocity minus an initial velocity because in this particular question, we're only given one velocity. So we don't need to do a final minus initial. If you want to, you could do your final of 4.25 meters per second minus 0, which is where the car started initially, but we don't need to show that. If that confuses you, just start with A equals V over T. We're going to plug everything into our formula. So 4.25 meters per second is divided by, so that's what this means, divided by 6 seconds. If you plug that into your calculator and divide the two, you should get 0.708 meters per second squared. Now, in this case, acceleration is in meters per second squared, not meters per second, not kilometers per hour. We're going to go with meters per second squared. So you'll see as we move through a couple more examples. This example gets a little bit dicey. This one gets a little bit more difficult because we are going to have to do a little bit of a rearrangement. So it says a bike starts from rest and obtains a final velocity of 2 meters per second south, while accelerating at a rate of 0.50 meters per second squared. How long did it take for the bike to gain the velocity of 2.0 meters per second? If we were to take this out and look through, we would then notice that there's a couple key pieces of information. We have a velocity of 2.00 meters per second, and we have an acceleration of 0.5 meters per second squared. We are going to be solving for time, which means we need to rearrange our formula. Reminding ourselves when we're rearranging our formula, we need to take t out of the denominator and bring it up beside the a. So we're going to multiply by t on both sides of the equation, and then divide by a to bring a to the other side of the equation. So that equals t equals v over a. We're going to then plug in our numbers. So there's my velocity and my acceleration, and we're going to end up with 4 seconds. This example now is utilizing our final minus initial, and there's one step in here that's a bit more difficult because we're going to do a conversion. I don't necessarily will ask you for conversions on quizzes and tests, but I will just show you a quick trick on how to convert if you get stuck with something like this. So you have a car with a velocity of 50 kilometers per hour, and it accelerates to 60 kilometers per hour east in a period of 4.5 hours. Now, this isn't really realistic, but I originally had seconds. That didn't make sense. So we're going with hours, but we know that's not true. That wouldn't take us 4.5 hours to accelerate 10 kilometers, but we're going to just work with it. So we're going to go with our final minus initial in this case because we have two different velocities. So our final velocity was 60, our initial velocity was 50. So we're going to subtract those two from each other, and we're going to divide it by our time. In the end, we get 2.22 kilometers per hour, okay? Now, what this question is going to ask is what is the acceleration? And we know that acceleration is in meters per second squared. So we did a bunch of conversions in class and we moved from kilometers per hour to meters per second. And then we learned the trick of multiplying or dividing by 3.6. So in this case, we're going to divide by 3.6 and we're going to get our 0.62 meters per second squared east. Because remember, acceleration is a vector, so we are going to show direction. All right, there are a bunch of practice questions in your note package you need to try, and we will be going over them in class.